This video is going to show you how to calculate the statistical power of a hypothesis test. The statistical power, or just power as we'll refer to it from now on, is the probability of correctly rejecting a false null hypothesis at a specific value of the alternative hypothesis. Basically, we're asking ourselves, if the null hypothesis is false, what is the probability that our sample picks up enough evidence to reject the null hypothesis if the true population mean is actually some specific value from the alternative hypothesis. So the power is the probability of correctly rejecting a false null hypothesis at a specific value of the alternative hypothesis. Keep that definition in the back of your mind as we look at this example. A reputable source claims that the average number of hours a college student spends on the internet each week is 20. The population standard deviation is known to be 6 hours. However, you think this average is too low. If we were to perform a hypothesis test, the null hypothesis would be mu equal to 20, and the alternative hypothesis would be mu greater than 20. However, rather than doing the hypothesis test, we want to answer a different question. If the true average number of hours that college students spend on the internet weekly is actually equal to 22, what is the probability of rejecting the null hypothesis at a 5% level of significance? Here's how we're going to approach this. First, assume that the null hypothesis is true in order to determine how much evidence we need to reject it. We need to know how large the sample mean has to be in order to be considered significantly greater than 20. Then, we'll find the probability of obtaining that evidence if the alternative hypothesis is actually true at a specific value. In this case, that specific value from the alternative is 22. To test your claim, you take a survey of 40 randomly selected students at the university and ask them to record the number of hours they spend on the internet this week, keeping in mind that the population standard deviation is 6 hours. So to figure out the first part, we need to know how much evidence we need to reject the null hypothesis at a 5% level of significance. How big does X bar need to be in order for it to be significantly greater than 20? The first step is to find the z-score that corresponds to 5% of the area in the upper tail. The standard normal distribution is centered at 0. Since we want 5% of the area in the upper tail, we need the 95th percentile. This z-score is the cutoff between rejecting the null hypothesis, which is what happens if our test statistic falls in the blue region, and failing to reject the null hypothesis. More specifically, this z-score is called the critical value. Critical values are percentiles that define the boundary between rejecting the null hypothesis and failing to reject the null hypothesis. They depend on the level of significance as well as the sidedness of the test. We reject the null hypothesis if the test statistic is more extreme than these values. This chart summarizes the critical values for the 3 different types of tests at 4 different levels of significance. In this case, we have an upper one-sided test at the 5% level of significance, so our critical value is 1.645. What this means is that the 95th percentile of the standard normal distribution is 1.645. So if our test statistic were to be greater than 1.645, we would have enough evidence to reject the null hypothesis. Next, we'll use this z-score to solve for the value of X bar that will allow us to reject the null hypothesis. We want to know how large does the sample mean need to be to reject the null hypothesis at a 5% level of significance. Basically, we need to know what value is 1.645 standard deviations above the hypothesized mean of 20. What we'll do is undo the standardization and solve for the 95th percentile. The 95th percentile is going to be the hypothesized mean, 20, plus 1.645 times the standard error, 6 over the square root of 40. Solving this expression yields 21.56. What this means is that 21.56 is the cutoff between rejecting and failing to reject the null hypothesis. We'll reject the null hypothesis if the sample mean is greater than 21.56 and conclude that the average number of hours that college students spend on the internet weekly is significantly greater than 20. Here's where the power of the test is going to come into play. Keep in mind that the power is the probability of correctly rejecting a false null hypothesis at a specific value of the alternative hypothesis. We need to know if the true average number of hours that college students spend on the internet each week is actually 22. What is the probability of getting a sample mean of at least 21.56 from a sample of size 40? Remember that a sample mean of 21.56 or larger will allow us to reject the null hypothesis. Now, the distribution on the left is the distribution if 20 is the true mean, the distribution if the null hypothesis is true. The distribution on the right is the distribution if 22 is the true mean, that is, if the null hypothesis is actually false. This blue shaded region is the probability of getting a sample mean of at least 21.56 if 20 is the true population mean. This is the definition of a p-value. However, we're looking for the probability of getting a sample mean of at least 21.56 if 22 is actually the true population mean. Suppose we're actually taking our sample from the distribution on the right. Assume that 22 is the true population mean and that our 40 observations are coming from the normal distribution on the right. What we'll do is we'll extend the critical value line up to the top of the distribution centered at 22. This red line represents 21.56, the cutoff between rejecting and failing to reject the null hypothesis. We reject the null hypothesis for values of the sample mean larger than 21.56. The area of this red shaded region is the power of the test, and it represents the probability of getting a sample mean of at least 21.56 if 22 is the true population mean for the number of hours that college students spend on the internet each week. At this point, we can finally calculate the power. We know that we need a sample mean of at least 21.56. We know the population standard deviation is 6. And we know that we took a sample of size 40 from the population. The power of this test, or the probability of rejecting the null hypothesis, mu equal to 20, if the true population mean is actually 22, is found by calculating the probability that the sample mean x bar is greater than 21.56 using a population mean of 22. Note that we use a greater than sign here because the alternative hypothesis is upper one-sided. Standardizing gives us the probability that z is greater than 21.56 minus 22 divided by 6 over the square root of 40. This gives us the probability that z is greater than negative 0.46. Using the standard normal table, we find that this probability is 0.6772. So the power of the test, mu equal to 20, versus mu greater than 20, using a value of 22 from the alternative hypothesis, is 0.6772.